we've looked at differentiating something in powers, right? So for instance this. Okay. We just showed that it was equal to 2x. Okay. But what happens when you slap a constant coefficient out the front? Okay, for instance, if I was differentiating 5x squared. Okay. Now, for some of you might think, well, it's very obvious, isn't it? I've got one of them here, I've got 5 here. So I'll take this and I'll just say, well, 5 of them. Okay. And this turns out to be true. However, this multiplying business doesn't always just lead to, or just put a 5 in front, okay? I'll show you why. Later on we have to learn this thing called the product rule, because when you multiply things together, if one of them isn't a constant, things go really, really different, okay? So that's why I'm going to show you why when it is constant, why does it work? Why can I just slap a 5 on the front of both sides of the equation? Okay, so let's go back to first principles. F dash x, right, is equal to rise over run. Okay. So if I take any function and slap a constant out the front, so if I say let c be, oops, some real number, any real number you like. Okay. If I take a new function and let it be the old function times a constant. Okay? What's going to happen is I work out its derivative. Well, let's go back to first principles. Okay? It's going to be the limit as h approaches 0 of. Okay, now instead of my f of x plus h, right? I've got a whole new function here. Okay, so it's a bit different. So I've got c times this part and c times that part. Is that okay? Nothing too dramatic so far. All over h, which is the run. Okay. Now, what can I do with this c? I can take it out, I can factorize it out, but the question is why? Why can I just say this c out the front, and then I've got the rest of the limit over here? Why can I take it out? Because if it was an x, there was an x here, right? I couldn't just simply take the x out. Or if there was an h, I couldn't simply take the h out. Why not? Okay. Well, let's think about this. Let's think of some examples. Now, examples are not a good way to prove things, but they are a good way to see how things work. Okay. So, for instance, let's go here. Let's take this. Start nice and simple. I've got a function, x. Okay. What's the limit of that function as x approaches 2? It's not meant to be a tough question.
3.
So it's 2, right? Now what happens when I take 2x, right? This is just a straight line, right? If I take the same limit of a steeper line, okay, it's going to get higher, right? It's going to be 4. Because you just think about what this line is doing. You know, this line, oh, I missed, sorry, versus this line. Okay, it's just getting to a larger number. So I can keep on going, you know, as I take out these constant coefficients, really what I can do is I can put this number at the front. It's 3 times the limit I started with. Can you see why? If it was, say, an x, right? If I took the limit as x approaches 2 of, say, x cubed, okay? I can't just put, this is not equal to x squared times the limit as x approaches 2. They're quite different, okay? Because this would be equal to 2x squared. But actually it should be 8, right? So what's going on? The reason why I can take out, let me get another color. The reason why I can take out this number out the front, right? And I can take out this number out the front, okay? Is because c is independent of what my limit is, okay? 3 is independent of what my limit is, but here x is not, okay? So therefore, this part here is just this part, right? It's just the first line, okay? So it's c times your derivative, okay? So if I differentiate something with a constant at the front, you can actually ignore the constant and drag it out there, and then deal with it later after you've actually differentiated, okay? So therefore, how can we use this? Let's look at a practical application. Let's take x squared, okay? Or slap the coefficient at the front. Okay? If I wanted to find, say, the equation of a tangent, what's a tangent? How would you define a tangent? I'll give you a clue. Starts a straight line that. A straight line that what? A straight line that touches the curve what? At one point. Okay. So be careful, right? A straight line that touches this curve at, say, one point. Well, I could draw a straight line like this. And it hits at one point, right? So we need to be a little more specific, yeah? We want to say that at the point that it passes through, right? It's not just doing whatever it wants. It has to have the same gradient. Okay, like that. So we call it a tangent because it comes from the Latin word for touch, which is which, by the way, we get another English word from. Tangerine.
Tangible.
Tangible, thank you. So things that you can hold with your hand, things that you can touch. Tangerine. Anyway, sorry.
Touch this tangible.
Yeah, that's right. What were they thinking when they discovered the first? It's like, well, I guess you can touch it. So yeah.
It's not a hologram.
And then they discovered the orange, and they're like, oh, what are we going to call this? It's orange. Okay, so I want to find the tangent. It's going to be a straight line. Okay, it passes through a particular point, and it has the same gradient as that point. Okay, so this is y equals 5x squared. Okay, let's pick a point, like say 1, well, when x equals 1, what will the graph equal? 5, right? 5. 1, 5. Okay. Hey, we've talked about this before, that x and y can have totally different scales. Okay, let's keep going. To work out what the equation of this line is, right, you need two things. Number one, you need the point that it passes through, so that's fine. But then you also need its gradient, which is why we differentiate. Okay, so what's the derivative? Well, it's just 5 times 2x. I'm just putting that in to make obvious that I'm differentiating this on its own. Okay, so there's my 10x. So the actual value of x that I have is x equals 1, right? So I'd say when x equals 1, there's my gradient. Does that make sense, by the way? Is that a sensible result? Yes? No? Why? Why is it? I agree, it is sensible. How do you know? On what grounds do you say? Apart from Evan, who said it's ridiculous. I think it is sensible. Admittedly, my graph doesn't show it off well because my scale is not very good. But 5x squared, it's a parabola, and the 5 makes it a super narrow, super steep one, right? And 10's a steep gradient, so I actually think it's consistent. Okay? So therefore, if I want to find out the equation of a tangent at that point, 1, 5. Okay? What kind of form of a straight line am I going to use? I've got its point, and I've got its gradient, so I use point gradient. Okay? Which looks like this. Okay? Is that alright? So y minus 5 equals 10, x minus 1, and what form should I put it in? I haven't asked for any form, so probably general form, right? So I'll take that 10x minus 10, y minus 5, what should I do here? 10x minus y minus 5. Is that okay? Okay, so, not so hard. And can you believe that for hundreds of years no one could work this out? And you guys are like, oh, this is really basic year 11 maths. I can handle this.